Okay, good day viewers, good afternoon viewers, and good night viewers. Anytime you are watching me from, please always do well to share and do well to like and do well to comment. You must always comment. Let's attempt this man on the board. They lose complex but not that complex. Let's attempt him. If we have this is what we call double integration. It is called double integration where we have our integral, first integral, second integral, then we have a range into this function of the a. This simply means that what we have here is that we have been given range of x and y. We use double integral to integrate two functions. When we have two functions, f, x and y, we use double integral to integrate two functions simultaneously. That is the essence of double integral. So let's continue. We have been given a range arrow into x, y, where we are told we are given the first range. The range ranges from 0 to 1, and then the second range ranges from, for x axis, the range ranges from what? 0 to 1, and then for y axis, the range ranges from 0 to 2. So let's solve. Our dA, please don't be confused. Our dA is represented as dx dy. Don't understand now? For this dA, don't be confused. So I can easily rewrite this expression to be integral of our first range 0 to 1, integral of our second range, which is what? 0 to 2, into 2y minus 3x squared y squared. Instead of dA, I will put dx dy. Remember I told you, I said this integral of double functions is used to differentiate two functions simultaneously. So can we go on? Let's go on. Okay, let's integrate dx in respect to dx first. If I'm integrating in respect to dx, I will take this 1 from 0 to 1, 2y minus 3x squared y squared to dx. I'm differentiating in respect to what? To x. That's why I leave dx and then leave the dy. Okay, integrate this function. If I'm integrating a function that there is no, if I'm integrating a constant simply means where what you are integrating to in respect to is not there. So I will regard this as a constant. If I'm integrating a constant, I'll get 2xy minus integrate this constant now. This multiplied by this now will give us, we have this now. Sorry, since we are integrating, it will be what? An addition of 1 divided by what? Our power, which is what? 3x raised to power 3 divided by 3. Then we put our y square there. Since I'm integrating, and then we have a range value, I'll put our range value 0 to 1. Do you understand now? So let's continue. By continuation, I have, from here now, we have 2xy minus this. This can easily strike out this. So we are left with 2xy minus x cube y raised to power 2. All these ranges from have a range value of 0 to 1. Easy as it is now. So now we have 2xy minus x raised to power 3 y raised to power 2 ranges from 0 to 1. This simply means whenever we have range value in mathematics like this, it simply means that I can easily take our upper bound, which is 1, the upper bound, which is 1. So x, we can represent x with the upper bound, which is 1. So we have 2 times 1, y, minus 1 raised to power 3, y raised to power 2, minus upper bound minus the lower bound. This minus the lower bound, which is 2 times 0, y. This automatically 0 minus 0 raised to power 3, y raised to power 2. Understand? So automatically, this side is equal to 0. So we leave this side because automatically it's 0. 0 changes 1, 0 changes 1. So what we have here, we have 2y minus y raised to power 2. We have 2y minus y raised to power 2. Remember, we have double integral here. So we've integrated in respect to x now, and we got this as our final answer. Then what we have to do is to integrate in respect to y. So if we're integrating in respect to y, remember that our range value in y was from 0 to 2. So integrate this function in respect to y. If we are integrating it in respect to y, we have integrate this now. We have 2y squared divided by 2 minus integrate this now. You have y raised to power 3 divided by 3. Yes, you add 1 to it. You add 1 to it. Divide by what? Divide by 3. Let's confirm that. Then going further now, all these ranges from what? Sorry, rather, all these ranges from, was it y square? Okay, we have y square and y was y square. Okay, yes. All these ranges from 0 to 2. So this we strike out this. We have y square minus y raised to power 3 all divided by 3. But remember, this ranges from what? This ranges from 0 to 2. So if it ranges from 0 to 2, that means automatically our 0 as is equal to 0. So we won't calculate for 0 because 0 automatically is 0. So let's calculate for 2. So y equals to 2. So we have 2 raised to power 2 minus 2 raised to power 3. 2 raised to power 3 all divided by 3. Then 2 raised to power 2 will give us 4 minus 2 raised to power 3 will give us 8 over 3. You know, in mathematics, elementary mathematics, look for the LCM. You look for the LCM of this now, you have 3. Let's say here is over 1. 1 into this will give us 3. 3 multiplied by this will give us 12. Minus 1 into this will give us what? Will give us 1. 1 multiplied by this will give us. So we have 12 minus 8 divided by 3. 12 minus 8 will give us 4 divided by 3. So the final answer to our double integral of this function will give us 4 over 3. I get to learn anything today. Not too hard. It's very, very sweet. Thank you. Please do well to always share. Do well to always follow us, and comment to all our channels and all our videos. We love you all. Thank you so much.